Alright, here we have the problem of a very dilute strong acid solution, and we have therefore two significant sources of H3O+, the strong acid reacting with water and water reacting with water. The second source, water reacting with water, or the autoionization of water, always is ongoing, but it's usually not a significant source of H3O+, and we generally ignore it. In this case, since we have such a low concentration of our acid, it can't be ignored. Alright, so let's consider the first source. All of the strong acid, the nitric acid, is going to react with water and produce hydronium ion and nitrate ion. So we're going to start with this amount of H3O+ ion present when we consider the equilibrium of water reacting with water. Our ice table of the autoionization of water, pure liquid here in the reactants. We don't care what these concentrations are. Here are our products. Again, initially we have some H3O+ ion from the strong acid, and we assume we don't have any hydroxide ion prior to the reaction occurring. Alright, so we've input our equilibrium concentration into our equilibrium expression, and we want to test to see whether or not we can make the simplifying approximation. Alright, so we find that our approximation is not okay, so we're going to have to solve this using the quadratic equation. Alright, all we've done here is multiplied out this side of the equation. So we have 5 times 10 to the minus 8 times x plus x squared. Now we put this into the form of ax squared plus bx plus c equals 0. Alright, so we have our values of a, b, and c. We can solve to find our two roots that solve the quadratic equation. Alright, so we have our two roots, only one of which is going to make physical sense. The only one that makes physical sense is this first one. Now that we have x, we go back and answer a question. The question asks us to determine the pH, and we have some amount of H3O+ from the strong acid and some amount from the autoionization of water. So we can add these two values together here to get our concentration of H3O+ and then on to the pH. And finally, we're at our final answer. We have pH is equal to 6.89, just a tad more acidic than pure water.